Hello guys, welcome to Pepcoding, and today we will gonna solve a question which is unfold of a linked list. Let me tell you, let me show you its statement first, then we will understand the question statement, and after that we will gonna solve it. So we have given a singly linked list, okay, and it is given to us in some order, and we have to unorder it. Let me tell you how it is. So we have done a question previously which is fold of a linked list. So if you haven't done that question, so do that question first, which is fold of linked list, and then come to unfold of linked list. Because okay, so I will start this question now because I assume that you already did that question of fold of a linked list. So let me start it. So we have what we have given is we have given uh, we have given a linked list which is already fold. So if A I D H, so first of all let me tell you how it is folded. So we have a linked list which is A B C D E F G H I. We have this kind of linked list, okay, and we have given its folded version. This is not our given linked list. I'm telling you right now how to fold. Okay, so the folded version will be something like this. A is connected to I, connected to B, is connected to H, is connected to C, is connected to G, is connected to D, is connected to F, is connected to E. This is the folded version, right? So what you have to do is this is given to us and we have to convert it to this. This is our output, our output value. Now understand the question statement. We have given a folded linked list. We have given a folded linked list and we have to return its unfolded version. Okay, so let's start it. How we can do it. First of all, let's analyze this folded version. This is our linked list. Let's analyze it. So right now we start from A and we skip every one character. So we jump every two times. So A, then B, B then C, C then D, and after D it's E. And also we jump in the same way from here. I, then H, by skipping every one character. G and F. So right now if you see, we have something like this. We have our list in this manner. If we write it in this manner, so A, then B, then C, then D, then E. After that we have, if I go from reverse order, F, G, H, I. Isn't it the output? It is, right? It is the output. So if somehow there are some ways to do it, but we have to do it in ON. And we have to do it in ON time complexity. So we can, and the second thing is we cannot take some extra space. So now we know that we have something to do with their pointers. We can only do something with their pointer. We have nothing else to do. So now we know some things. First is skip every alternate character. Alternate character. Or I'll say every alternate node, not character, node. Second thing is the list which is starting from second. The list is starting from second place. Second place need to be reversed. Need to be reversed. Because if you see, if we analyze it, we will get our linked list in such way. I is connected to H, which is connected to G, which is connected to F. But we want F, which is connected to G, which is connected to H, which is connected to I. We want this. After this, we get this, we get reverse of this. We just have to do what? We have to connect them. We get our output, right? So the last part is connect. Isn't the approach, isn't the our algorithm first skip every character and get two lists. First we will get which is in their correct position. Second we get is in their reverse order. So we have to reverse the second linked list to get it in its correct order, right? To get it in its correct order. And after that we have just to we just have to connect both the linked lists, something like this. We have to connect and we get our output, right? So let's start doing it and we will see how we can do it. Let me erase it first. Erase these things. Okay, I'll write them again. So we have a linked list, something like this. A is connected to I, is connected to B, connected to H, is connected to C, which is connected to G, is connected to D, connected to F, is connected to E. The first thing is how we can get these two lists to start from here. We will take four pointers, which is first head, second head, first previous, second previous, and forward. We take these 5 pointers. At our initial phase, we take these 5 pointers. Now what we will do? Question is what we will do. So we will do what is first thing is connect first previous with forward. Connect first previous with forward. The second thing is connect second previous. First thing we need to do is connect first previous with forward and connect second previous with forward dot next. This is the first thing which we need to do. Connect first previous with forward and then second previous with forward dot next. Two things are done. And then after that, what we need to do is we need to take first previous at first previous dot next, second previous at second previous dot next, and forward again to here. Like we take them, then again do the same thing. Again we have to do the same thing. So what we need to do is connect first previous with forward. Connect second previous with forward dot next. And then again take them. Okay, something like this. Then again first previous to forward, second previous to forward dot next. Then again take them, go here. And one more thing, one more time, first previous at forward, second previous at forward dot next. So now what is the list we get? We have a head of first list, we have a head of second list. So let's understand what is our FH list, which is starting from FH. We have A connected with B, connected with C, connected with D, connected with E. And we have SH, which is what? I connected with H, connected with G, connected with F. And one more thing. Yes, one more thing. We have to remove these bonds, right? Because these bonds are already broken. When we change their configuration, these bonds are broken. Now there is no need to of these bonds. So now we have this list A, B, C, D, E, I, H, G, F. Now if you understand, I, H, G, F is in reverse order. We have to connect E with F, right? But in the reverse order. One more thing, this is our 1 2 3 4 5 6 7 8 9. Odd number of list, odd number of linked list. So let's understand even one at one time. Let's go for even also. We have something like A connected with B, connected with C, connected with D, connected with E, connected with F, connected with G, connected with H, connected with I, connected with J. Yes, okay. Its folded version will look something like this. A connected with J, connected with B, connected with I, connected with E, connected with H, connected with D, connected with G, connected with E, connected with F. Okay. So we will take the same way again. We will take okay. So first head, second head, and first previous, second previous, and forward. Okay. So first of all, we make pointer to A2 forward and this to this, and then we move all of these three to here, right? Then again do the same thing. This will go to this. This will go to this. Just move again. Move all of the three. Okay. Then again this to forward. Second to forward dot next. Then move both of them again. And then for time forward to forward, this to this, then we will move them both of them again. Now one thing which I need to tell you now, we get our list, right? But if I try to move them again, move both of them again, or let me tell you one thing, if I need to point them, so this will be there is null, right? If I need to point this, forward will be point to null, which is correct. But then second previous will be pointed to null dot next, which is nothing. So there will come a exception. So how we can handle it? We have to stop this termination. We have to find some termination point, right? But where? Question arises where? Because we cannot move it. We cannot move it further in our odd values. In our odd values, what is happening here is after this point, if we move them, we get our null at where? Second point. We get our null here at our second previous. We get our null, but here the thing is we get null both. We cannot point them. This is the problematic thing here. So to get that termination point, there's something which we need to do. So we need to find that termination point, right? So all that. Just listen to me. There is this termination point which I can write is like this, right? What? While second previous is not equal to null and second previous dot next is not equal to null. At that point, we can terminate. And write this condition, right? Okay. So let me explain it once more. This is our two conditions. In this, we have odd. We have odd number of element 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9. This is even 1 2 3 4 5 6 7 8 9 10, right? So here we get this, right? So here if you see sp dot next, sp is not equal to null. Okay, sp dot next is not equal to null, right? Sp dot next is not equal to null. So in this condition it will terminate from here, right? And in this condition it will terminate where? It will terminate from here. When sp dot sp dot is not equal to null. Right? When sp is second previous is equal to null, it will terminate here. This will terminate right here. Because we cannot point or pointer here. In this after this we cannot point. Right? This should be our termination point in this, and this should be our termination point for odd, and this should be for even. So to for both of them, we need a condition, and for that this is the condition which can be satisfied, which is as the second previous is not equal to null and second previous dot next is not equal to null. Okay, now you understand. Now let's code it out. Okay, so let's go. So this is our Java portal. So let's do. First of all, let me make it full screen. We're going to solve it in this case. So first of all, for the base condition, head is equal to null, or head dot next is equal to null. If this condition occurs, we can return from here. After that, list node 1 is equal to head. List node h2 is equal to head dot next. Let me tell you which I did, which is what is the example which I what is the name I took in our example. We see I will F1 and F2, F head, first head and second head. Okay, so F1 and F2. This is H1 and H2, right? And then second thing which we'll take is FP and SP. Okay, FH and SH, FP and SP. Okay. We'll take F, H and SH. These are the two heads, right? So that we what we need to do is list node FP, first previous, is equal to one list node second previous is equal to SH. This will be FH. After that, we just need to make while loop. While for second previous, right? So SP is not equal to null and SP dot next is not equal to null. If they occur null anywhere, we'll terminate our loop. In this while loop, what we need to do is list node f is equal to sp dot next. This is what? This is our backup. Forward, right? This is our forward. So that our we cannot forget the next element values. Okay. So after that, what we need to do is link. So first of all, we link what? We link fp dot next to f. The second thing which we need to do is sp dot next to f dot next, right? Then we have to move. So we have to move fp is equal to p dot next and sp is equal to sp dot next. We did these two things, right? After coming from this loop, we need to do one more thing, which is we need to connect, right? So one thing which we get two lists, which is now fh and sh. We get two lists. Now the thing which we need to do is we need to connect fh and sh. Let me tell you in our open board. So after this, we get this. So there are two things which we need to do. First is we need to reverse this, right? So first is we need to reverse. We have already made the video for reverse. So if you don't know how to reverse the linked list, so first of all, go there, pause this video, go there and watch that video. Reverse and then connect. Right? This is what we gonna do now. Okay. So when we go out from the loop, we do what? We need to reverse our linked list, right? So we will make a function of reverse in a second, but we need to do what? We need to sh is equal to I will say we will update the head. So sh is equal to reverse. I will put sh here. Second head. We have to reverse the second linked list, right? So in this function we will do that. And after that, we just need to do what? We need to do fh dot next. Not even fh. We need to do fp dot next is equal to sh. I will tell you the meaning of both these statements. But first of all, let me write the code for reverse. Okay. So public static list node reverse list node. Then if node is equal to null, or node dot next is equal to null, we need to do what? Return t and node. I assume that you have watched that video for the reverse, so you know how to reverse the linked list. Okay. So list node previous is equal to null. List node current is equal to node. Then while current is not equal to null. Current is not equal to null. List node, we need to make one more pointer, current dot next, which will be point to current dot next. After that, current dot next is equal to previous. At last, current is equal to a go forward. And at last, we need to do what is return return forward. Sorry, return previous, because previous it is the head of our reversed linked list. Okay. So now understand these two. First of all, we reversed it. Okay. So let's go to the code again. So here we need to current what? E is at FP, right? So we need to current FP with SH, right? This is what we need to do. FP is at E. We need to connect our E to SH. So we did this here. FP dot next is equal to SH. So let me run this code first. Let me check if there are any compilation error. So there is a wrong answer. Let me see what is the wrong. So let's check. Okay, everything looks fine here. Okay, SP now everything fine. Okay, reverse. Let me check my reverse list. So I will do forward to current dot next. Okay, and current dot next is equal to previous. Current is equal to forward. Sorry, before that we also have to do one more thing, which is previous dot. Sorry, previous is equal to current. Right. So let me check it again. And so the correct answer right now. Kept it. Let me submit it. It is taking longer time, but corrected answer. So one more time, why our reverse list was long? Because I did not make previous to current. I did not move the previous pointer. So I make the forward pointer to current dot next, then current dot next to previous. But I have to move previous pointer also now. So previous pointer is equal to current and current is equal to forward. And one more time, the flow of this question is how. First of all, we need to put four pointers. First head, second head. First previous, second previous. Okay. First head to head, second head to head dot next. So from first head to second next, we get okay. Let me go to our open code and then I will tell you once more. That four pointers, first head, second head. So first head will give you first list. and second head will give you second list, right? Then we move them. We move them before that we take a F. We take F here, right? Why we take F here? Because of the backup. If we break the link, we cannot get the access to other elements, right? For that we make our F here and we connect this to this, then this to this, because every element is one more is at alternate distance, right? So I get my first list here, fh, second list here. Then what I do, reverse and connect. Reverse the second list and connect it with the first list. This is the all flow. So thank you so much, guys. If you understand the concept behind it, if you now know how to unfold a linked list, and if you like the video, please like. If you have any query regarding this question, please comment and subscribe to our channel. Thank you so much, guys.